Hello everyone, my name is Ashkan, and in today's tutorial I'm gonna talk about the difference between block and bleed valves. First of all, we all know that the main design and construction standard for block and bleed valves is API 60. According to this standard, we have some definitions about block and bleed valves. First of all, block valve is a kind of gate, block or ball valve that blocks flow from downstream. The second category, which is known as block and bleed valve, is a single valve with at least one seating surface and a body which has a ventilation valve. The third category, which is known as DBB valve, is a single integrated valve with two block valves and a needle or bleed valve located between them. And the fourth category, which is known as DIB valve or double isolation and bleed valve, is similar to DBB, but the difference is in the pressure resources around the valve. Well, as you can see in Annex K of API 60, we have a block and bleed valve illustrated here. As you can see in the picture, we have a block valve and the pressure source is applying pressure from the left hand side, and a bleed valve is located separately, which is known as type A, or integrated into the block valve, which is known as type B. The next item, which is known as double block and bleed valve, is a kind of commonly used DBB valves for isolation in oil and gas industry. This type of valve is a combination of two isolation valve and a bleed one. Its primary function is to isolate a section of piping or equipment for maintenance, repair, or replacement while ensuring the safe release of any trapped pressure between the isolation valves. Well, the isolation valves, which are usually ball valves, provide a seal against pressure from both upstream and downstream directions. This is the main difference between DBB and DIB, because in DIB valves, which I will explain in the next slide, the pressure source is only applying from one side. In two types of DBB and DIB valves, a bleed valve is typically located between the two ball valves, and the function of these bleeding valve is allowing for controlled release of any residual pressure or fluid trapped in the isolation section. Well, the main advantages of using DBB or DIB valves is the space saving design, because it replaces three separate valves with a single one, and a reduced installation time and cost, a fewer potential leak paths due to a more compact and integrated design, and a full bore design with a low pressure drop. And as I told you, DBB and DIB valves are both used in oil and gas industry and petrochemicals and power generation units. And in this slide, which is the section K4 of Annex K of API 60, you can see the illustration of DIB valves, which is known as double isolation and bleed valve. And the main difference between this one and DBB is the sign of pressure source. In these DIB valves, the pressure source is only from one side, but in DBB we have pressure from both sides. And like DBB, we have two types, type A and B, and the main difference is that in type A, the block and bleed valves are located separately, but in type B, all the three block and bleed valves are integrated in a single unit. Well, in this picture, we can see a DIB or DBB valve, and I named it and I titled it as a DIB because the pressure source is only from the bottom of the valve. But overally, you can see two levers, which are for the ball valves inside this unit, and a needle valve behind the lever, and its functionality, as I told you, is reducing the pressure between the two block valves or releasing a trapped fluid between them. For doing some repair or maintenance for field instruments installed above the valve, you have to block the flow, and DBB or DIB valves can do this easily for you by closing, first of all, these lower block valve, and in the second stage the upper block valve, and in the third stage by opening opening gradually the needle valve, we can release the pressure between the two block valves, and after that you can finally remove the fill instruments installed above the DBB valve. And in the final slide, you can see a DBB or DIB valve. As I told you, we have two block valves, which are ball type, and a bleeding valve, which is a needle type located between them. And the application of needle valve, as I told you, is reducing the pressure between the two block valves after closing them. As you can see, the type of the end connection is flange type, but we can have all the types of end connections like screwed or threaded connections or second weld connections, because these types of valves are mostly used for isolation of fill instrument facilities, and those instrument facilities are mostly in lower sizes below 2 inches, for example 1 inch or 1.5 inches. And in these type of connections, in these range of sizes, it is better to work with some threaded or second weld connections. And so we can have, for example, one side with flange connection and the other side with threaded connection for connecting the instrument facilities. This DBB valve is API 3000 and the size is around 2 inches, and the length of the valve is 350 millimeters. The approximate weight of this DBB valve that I showed you, the real picture of that, is 75 kilograms. Okay, everyone, thank you for watching this video. Please like, comment, and subscribe, and introduce us to your friends. Thank you. Bye bye.